Hi, I'm Mike Vergalla, and I want to talk to you a little bit today about generative design and why I think that my project is a good proposal to work with CERN on an artist collaboration that merges science and art. I've been working with generative design with the Autodesk research team for the last 2 years. I originally started using it to design spacecraft. I'm presenting a project called Generative Accelerator to the CERN Artist in Residency. And this project utilizes a software called Dreamcatcher, which is in the Autodesk research group. And the software is a process of discovery. As it's a tool that is being developed right now, and as that tool gets developed, I ask it for harder and harder things. The way the tool works is you take existing geometry and you apply loads and boundary conditions and constraints to it, and it synthesizes geometry between the two or multiple geometries that you put into the computer. And this process is a collaboration in a computational form, and you end up getting thousands of designs back that you have to sort through different criteria. One criteria might be manufacturing process, another criteria might be cost, another criteria might be total strain energy. So as you're discovering these designs, you can't unsee the designs. And so where I think of it like CERN is that as you're finding new particles or as you're exploring new particles, you can't unfind something that you find. And there's a feedback loop where as a designer, I'm seeing 10,000 designs, and now it changes the way I design parts. So I'm very interested in taking this type of software tool and applying it to larger and larger scale problems. And CERN has always captured my imagination. In 2010 I got to visit. I saw the AMS being calibrated before it went to the space station. I got to see the superconducting cables that carry as much current as a giant bundle of copper. I was amazed at how much data was produced during each test run and how many collisions were happening every second, every minute. And what's similar about the generative design software is that you're getting thousands of solutions, and you have to down select from the solutions and search through them for the thing that you're actually looking for. This project consists of utilizing advanced design tools that leverage computation to make a component for the CERN experiment or ATLAS experiments that either replaces a component that's there or makes a new component for a future experiment. I plan to make the component out of aluminum or steel, and at the moment I plan to design it to where it can be conventionally milled on a CNC mill, which I'm trained to use at Autodesk Pure 9. Or I could metal 3D print it as well, depending on the application and depending on if it does plan to be used or doesn't plan to be used. I'd prefer to make something that's relevant, that can actually be used in the field or be used during an experiment, because I think that the tool, the generative design tool, and the way I want to apply it will both be beautiful as well as functional. And I strive to make things that actually have some scientific and engineering merit. I think that future engineers and designers will be using generative design tools as a computationally collaborative partnership. And part of the work that I'm presenting is to try to unlock that, is to try to use this tool for not only design objects like lanterns, but to use the tool for building aerospace components, for building scientific experiments, for payloads for suborbital flights, because I'm really interested in understanding the research applications, not just the beautiful aesthetics of this design tool.